Alright guys, got another video here for you. This is kind of an addition to my first Motion Sims or Easy video I did. This one is about wind sims. So if you've never seen wind sims, this is what the big version of them look like. A lot of versions will use smaller fans like these, or those cooling fans down there. They're basically system fans, which can be pretty powerful, like the ones I've seen on Amazon. You know, they're still doing like 150, 160. Some of them I've seen do up to like 210, like the expensive ones with double ball bearings and stuff. They'll go up to 210. Each one of these is 270 CFM is what they're measured in. That's cubic feet per minute. So you know, imperial units for all you metric people. I don't even know what you measure fans in. But these are 270 CFM, so these are on the more powerful side. They're 12 volt. The reason I get 12 volt instead of the fans here are 24 volt. These cooling fans, the system cooling fans, like if you want to get the 170, 200 something CFM, then they pretty much have to be 24 volt to go that speed. These are 270 with 12 volt. And since they're 12 volt, that means you can use the Monster Motos. Because the Monster Motos, I think, only go up to 18 volts. They won't do 24 volts. So otherwise, I'd probably get 24 volts. But you can still get powerful, more powerful than this 12 volts. Like some people use radiator fans. Those would really be the big boys, because those are like up to 1800 CFM, like 1600 CFM. But they're bigger than the size of the wheel, and 1800 CFM would, since they're so big, you would only need like one or two of them. It wouldn't be good to be able to do differential thrust, which is something that you'll need. Well, something that you can set up, let's say, not something that you necessarily need. I would say baseline, you need at least one motor, right? Baseline, at least one motor. But the Monster Motos, depending on how you buy them, I bought the double H bridge, and so it's 2 channels on that board there. You can, I think, buy them as single channel. If you do that single channel, then you can just do one motor. But it also, if you do the single channel, you can't just pop them directly on top of the Arduino. Like the red board up there is the Monster Moto, or Moto Monster, I forget what it's called. And then underneath that is where that USB is plugged into. That's the Arduino board that it's sitting on top of. So each one of those is a Monster Moto and then an Arduino. The Monster Motos are a little bit pricey. Last time I checked, when I bought those, 2 of those were 80 bucks, so 40 bucks a piece. So that is a bit pricey. I think if you buy the single channel ones, you can get them for maybe 20 bucks, I want to say, maybe 25. I don't really pay attention to those too much because I don't ever want a single channel. I like them, once you solder all the pins on, they just pop down directly on top of the Arduinos, and I like that. Instead of having to wire pins and wires over, it'd just be a lot more work. I guess not a tremendous more amount of work. I would just have to figure out a mounting for it, and that can be a pain. But it's certainly something you can work around. I just don't like dealing with it. I just buy the dual H bridge, so the dual channels. So I bought 4 more of the same fans that I had. Like I said, these are 12 volt, 270 CFM. I think they're like 6 volt or 6 amp nominal, 12 volt peak. Yeah, or 10 amp. Sorry, they're 6 amp nominal, 10 amp peak, or 10 amp fuse. So that would be their peak. You'll blow the fuse at 10 amps. So I bought these for the 6-off I wanted to build, but I'm still in the process of building that. These cases I've shown before, I got these popped off and got the bolts grind it off there, so that way the caps can go on now. But I want to be able to pull the shaft out of the housing to be able to lube everything up, and the gear is beveled, and so in order to get all the grease down below that gear, you got to pop that gear out. But these are kind of stubborn. They're really stubborn, and so I'm pretty sure it's the bearing that's pressed into there. I got them out of these gearboxes. Both those gearboxes, I actually pulled the entire shaft out, and that was so long ago that I can't remember how I did that. And I want to say when I put them back in, they never kind of ran right after that. So I might figure out a different way to just smash the grease down in there, and then I just gotta pop these off, clean this up, and weld that up. But back to the motion, or the wind sim. So the wind sim is very easy. I mean, I say that, and I'm not sure how many people thought that my last video looked easy. I thought it looked easy, but I'm 3 years into this, so a lot of things in this atmosphere look kind of easy to me because I have that experience. But I don't know how it gets easier than this. This one's literally like the difficult part is, let me come around. Let's see. The difficult part on these is that you have to solder these pins onto the board itself. They don't come soldered on. They come with the pins, they just don't come soldered on. So I would really suggest learning how to solder. Like, don't attack it if you don't know how to solder, because there's transistors really close to the pins that you have to solder, and that's how I messed up my last board. And I kind of touched those two transistors right there together, and the solder flowed between them, and that meant that the second channel doesn't function very well underneath 70%. From 70% up to 100%, it functions perfectly fine, but anything underneath that, last time I checked, it doesn't function. That's why the motion sim downstairs only has 3 motors, is because I mucked up one of these and I can only use one of the channels on it. So it's difficult. That's the only difficult part of this, is soldering these up. If you know how to solder, then obviously that's not difficult. If you don't know how to solder, I'm not an expert. I'll just tell you how I did it, but I would highly suggest you watch videos on how to solder. I would say that's kind of mandatory. But essentially what I did was I put the pins inside of the Arduino. It's got these little plastic things, so I put all the pins inside of here to seat them in the Arduino where I wanted them, and then I placed the Monster Moto on top. These were all holes right here that the pins pop through. So I got all the pins seated into the Arduino first on both sides, then I put the motor shield down on top, and then I fluxed all of this. Flux is stuff like that, solder flux paste. That's very important with soldering. I never really used flux, and I couldn't figure out why solder wouldn't stick to wires, and why, like, no matter how long I put the iron on there and tried to heat it up, I just could not transfer the solder from the tip of the solder to whatever object I wanted it to go to. Well, flux is the thing that helps you do that. You paint the flux on. I've got a brush right here that I use. I guess we'll just show you the whole thing. Yeah. I can't open this one hand. Hold on. There we go. Alright, so that's what flux paste looks like. And you basically get the brush, you get it in there, and you go dip, get it on the end of your brush. And then that Mac. And then if it's here, I can't touch it because it's on and has power, so we're not going to touch it. But basically, I would get it on there, and then I would just paint it along there, and then dip, and then go back and then brush it on the rest of these until it's all goopy and has flux all over it, right? Then you do that. Oh, let me put the paintbrush back. You do that for this side and this side here, right? There's less pins on this side than there's on this side, but still do it, flux both sides, and then you get the iron. Let me, oh, hold on, I'm twisting. You get the iron, and you would move the iron, you would put the iron on the edge of it and just try and touch like one of the pins, and then you would get the solder from this side, and you would feed the solder in and just touch it onto the iron. And then once you touch the iron onto the flux, it's going to start melting it and kind of bubbling around it. And then once you touch the solder onto the iron, it'll stick to the iron, and then it'll start to transfer onto the metal that's down here and the metal post that's there. And then you'll see that it just kind of, I'm trying to get it to focus. You'll see that it just kind of forms this cone. And once you see that little cone thing, you know, hey, that one's good. So then you move on to the next one. And then you just want to be careful that you don't put so much solder that it blobs over and connects any of these pins together. None of these pins should be connected together. I think I had one right there between 5 and 6, and I had to, like, I got a big blob of solder, and I just had to grab something and drag it through the solder while heating it to separate it. I think I just used a piece of welding wire, but you can use anything, safety pin, a paper clip. Oh, come on now. So that's the hardest part. And again, I'm not an expert in how to I am not an expert in how to solder. You should watch videos on it, but that's basically how I soldered this time without messing up either one of the boards. So I soldered both of those without messing up the board. Another thing that I did is if you get these if you get these motor shields, they do not come with these terminals. Usually on my last set, I just soldered the wires and soldered power wires onto it. And I think I put spade connectors on the power wires, but the motors are pretty much soldered directly on to the board. Actually, the boards are inside of the case, and then the case goes to the little connectors, are like B and C connectors, but they're not B and C. I don't know what they are, what they're called, but they go to those connectors. So that's why I got away with that, and that's okay. But for this one, I don't know exactly how I'm going to have stuff, and I want to be able to disconnect the wires from here easily. So I bought these terminals from Amazon. It's just these right here. It's a whole bunch of 2 pins and a couple of 3 pins. I don't really care about the 3 pins so much. I just bought them for the 2 pins for the motor shields, because everything else I buy typically has those terminal styles on them. So I bought those and got those soldered on. Same thing, paste, put the solder on, put the iron on, heat up the paste, the flux paste, and then put the solder on, wait till it becomes a cone, and then it's good to go. So soldered all 6 of those on, so now that's good. Why? There we go. So then I got 4 additional motors from Amazon. They're the exact same ones that I have downstairs. This is kind of pricey. The reason why I didn't do this one as my first video is motion sims were kind of my thing with that video. Building a motion sim is actually not as hard as you think it is, but the reason why wind sims are included in that is that I think wind sims are a big part of motion sims. Every aspect you can use to sell the effect is necessary, and it plays in harmony with each other like a symphony. So they're absolutely necessary, but another reason why they weren't my first video is because this setup right here was about $250, and I think all the stuff I showed in my last video was like around $350. So for an extra $100, instead of just getting Winson, which again, 4 is excessive. I'm pretty sure when I calculated just getting the power supply, getting the power supply, getting the Monster Moto, the Arduino, I would still buy the Arduinos in packs of 2 because it's $20 and you get 2 of them. So I would still do that deal if that's available. But that's $50. The power supply is like $30. $50 get you 2 Arduinos plus power supply, and then another $40 for the Monster Moto. So that'll bring you up to $90, and then each one of these fans are $30. So like $120 for that. I would say you need to get a cooling fan in there. I just bought, I have a ton of these cooling fans because I just found on Amazon a pack of 4 of them for like $20. They're not as powerful as these ones. These are ball bearing ones, but I think these ones are like $20 a piece. So I got 4 for $20. They're sleeve bearing, which means that they will eventually wear out, like they're going to die, because the bearings inside of them are brass sleeves and the friction will eventually wear it out. Whereas like ball bearings, eventually the steel balls will wear out and the raceways will wear out, but that'll be years, decades. Like as long as you don't rust them up, ball bearings are typically pretty good. So these ones will wear out, but I did test them and they still are pretty decent airflow. They're supposed to be like 90 something CFM. So they are still pretty decent, and you get 4 of those for $25, something like that on Amazon. And those just came in along with these motors. So it's going to cost you about $150, and that's that'll still give you 2 channels, and that's only if you get one of the motors. If you got another motor, then you'd have to add another $30 on there. So that's why I'm saying like it's $250 to just get everything. So you won't need to get more of the fans. You won't need to get more of the Arduinos because you're buying 2 of them. The only thing you would need to get is 2 more fans and another Monster Moto shield, which admittedly is another, what is that, $70. So anyway, that's the reason why I didn't put this in the first video, is because it is expensive. 4 is excessive. You don't need 4. 3 gets you everything. That's all the channels you can represent inside of Simhub. There's left, center, and right. So that's 3 channels. The way I have it set up is the 2 center ones are just the center channel, and then the left channel and the right channel. If you did just 1 motor, you would definitely do center channel. If you did 2 motors, you could do left and right and get differential thrust. Now what that means is that when you're taking a left-hand turn, the right motor is going to blow faster and the left motor is going to blow slower than if you were just driving straight, right? So you'll get the sensation that that the outside of your car essentially is moving faster than the inside. On a left-hand turn, this would be the inside, this would be the outside. So that's what differential thrust is. You only get that with at least 2 motors. I would say the reason why I say I don't think 2 motors is good. I usually say the minimum is 3 if you want differential thrust. The minimum is 1 because 1's still better than nothing. Having just something blow at you and having it set on the center fan set to speed is still better than nothing, 100%. But if you want differential thrust, then you need at least 3. The reason why is because when it goes into its differential, you don't have that constant force, and so it's very jarring. And also you hear those motors just like spitting up and down a ton when especially if you're doing like a chicane or something like that. But if you have center motors, then that will stabilize that motor will always stay at the same speed relative to your speed, whereas these will speed up and slow down relative to your speed and relative to the sway, essentially, of a turn. So you need at least 3 motors if you want differential thrust to be able to simulate that. I got 4 because the rig I have downstairs feels great. Like, I don't think that it needs it. It's just that I have it because I didn't mess up this other channel, and so I have 4 channels. So if I have 4 channels, then I might as well use all 4 of them. And it's only 30 extra bucks, but you are looking at $120 worth of fans just right there. And then that's $100 worth of Monster Motos and Arduinos, and then 30 bucks for the LED power supply. So, and then I'm not including the cost of this little guy in the package, because this little guy is a leftover from all of these. And these are for the 6-off. I'll need 3 of them for each one of the pairs of motors. So I'm building the 6-off will be a Stewart platform, and the way the Stewart platform works, it has pairs of motors set on the corner of a triangle. So it'll be a triangle, and then on each tip of the triangle will be 2 motors. And those 2 motors will be wired up. I don't know if I'm going to wire them up that way necessarily, because I want the 2 motors that should be surge, I want those wired up together. And so the 2 front, the 2 back, and the 2 middles should be wired up together instead of off to the side. But either way, I'll have 3 pods essentially for the 6-off, which means that I'll need 3 fans, 1 for each of those pods. And then running the motion sims, especially in Arizona, I pretty much have to have fans on the motors at all times. I could get more mechanical leverage, but I'd have to make stuff more, I'd have to make stuff bigger. Like, I'd have to make it come out further and then come out further this way, which increases the footprint. Or I could build a T-bar up, but then I would need to drastically increase the length of my lever arms, and I don't want to do any of that. So that's why I just put fans. This fan that naturally just cools the motors, cools the motor drivers, cools the motor, and then I added a fan there to cool that motor. So that is the setup for the new WinSim, and then the boards and everything were just temporary, just to test it and make sure that all of my solder was correct and I didn't blow anything up, which I didn't. It works great. I'll actually give you a demonstration of that now. This is gonna be 35%. Then we turn off the right channel. Why did that happen? I was going to show you the differential thrust, but it's not set up. It keeps deciding I need the left channel to be here and the right channel to be there, and those 2 to be the centers, but it keeps flopping between them, and it's making these 2 left and right. It's making that one left and that one right, which is great, but I need those 2 to be center. I mean, these 2 outside ones to be left and right. So I'm going to work on that again. But the temporary mount is not something that is going to be permanent, obviously. So I'm building an aluminum mount for this one, and whereas I had the diamond mount before with the X in the center to strengthen it, and I had 1 fan mounted on top, 1 on the side, 1 on the side here, so that way they could kind of swivel. They aren't so far apart that the differential doesn't really, you can't feel it on your face. You can't really tell the differential because all of them are basically pointed at the exact center of your face. I didn't want that. So this one is going to be basically set up kind of like how a triple screen mount is. I'll have this bar here that the 2 center motors will mount onto, and I'm gonna make like horseshoe, semicircle grooves in here, so that way the bolt here will be able to slide, so that way I can change the pitch. The other side will be screwed into here, but I want to be able to change the pitch of the motor, so that way I can angle these at my face. Then I've got this is all scrap. I'm trying not to waste as much as my whole stock as possible, so I'm trying to use as much scrap as possible. So I just gotta weld this up. I'm gonna put this piece on here, weld that on. The other motor will go on that side, and then that side will sit there, so this one can pivot. And then these are going to be the arms. I got to weld both of these on, and since I'm using pieces from the old shell that I built for my Ford-off motion sim rig back when I was trying to resolve motion compensation without using a controller, which was a terrible idea, I built a shell for the motion sim out of aluminum and then didn't end up using it, so I've got all that aluminum spare. And I've to make stuff collapsible so that way I could fit it in and out of doors if it was going to be mobile, I made these tabs and then drilled holes through them, and then they'll basically line up with these holes, and then you'll put a bolt through there, so then these will be able to swivel out back and forward, basically exactly like a triple screen monitor mount. So I'll have these out on both sides, and then I can change the pitch of those, or change the angle of those. And then underneath this bar, I'm going to get some aluminum welded on there, and then cut out another little semicircle, whatever the arc I need is going to be. But I'm basically going to weld a bar back off here, and then it will, this goes out of the way. Let's see, let's use this as demonstration. So we'll weld the bar back off there, and then this is going to be a pivot point here, and then I will weld 2 of these pieces underneath this bar. They'll go underneath there, and then they will have the curves in there, and then a bolt will go through. And the whole point of that, I'm going to weld 1 on each side, and the whole point of that is so that way I can raise this pitch up and down, because it's going to mount to the wheel hoop there, and I want it to mount like just above the wheel, and it's probably going to need to be pitched up a little bit towards the rider's face instead of being flat. I'm going to pitch it up a little bit towards the rider's face because I need it to still be lower than the monitors. I don't want it to intrude where the monitors are, and if you sit here where about my head is, it's clipping it, right? So these will get significantly lower. The wheel won't be able to sit underneath the desk anymore. And I also like playing in flat screen. I basically want a VR rig and I want a flat screen rig. So I still have 2 of my BenQ 24-inch 1080p monitors. I'm looking to buy 1 more of them, and if I get 3 of them, I'm going to set up my triple screen mount again, and I want to build off of the back of this tube down here, that one. Basically going to drill holes into it, and then have a plate that'll screw in there, and I'm going to weld something that comes off and then sticks up and then comes flat, maybe about this height, maybe a little bit higher, comes flat, and then my triple screen mount will mount to that. So again, this won't be able to be sitting underneath the desk. I'm gonna figure out a way to put it. I think I'm gonna tear down this desk, move all this stuff over here, because I won't need that monitor up there. I won't need my laptop. I can take all that stuff off, and I hardly ever use these tools, so that'll just be storage. So I might rearrange this desk, move that there, tear this desk down, move this simulator over here, just to kind of see what that's like with triple screen, and then have the mount for the WinSim. But like I said, it's going to be able to pitch up and down like this, and then the arms will be able to this is a better way to see it. We'll be able to rotate in and out like that. And I want them to be able to rotate in and out instead of setting them on a hard set, because if this arm comes out into here, this is where you step into the sim, and if it's in the way, I want to be able to move it out of the way. And then if someone's taller or whatever, I want to be able to adjust the sim to hit them in the face where it needs to be, you know, hitting them. So this is WinSim video. Right now I'm going to get to welding all this stuff up, and might do a follow-up video showing it, or I'll probably just show it off in a different video. So good talking to you guys. Talk to you later.